Hello students, welcome to this lecture 1 Permutations and Combinations. In this lecture, we will cover NCERT exercise 6.3, question number 1 to 11. So let's get started. This is disclaimer. So in this lecture, we will cover NCERT exercise 6.3, which contains 11 questions, question number 1 to 11. So make sure you are with your notebooks and pens ready, and let's get started. Look at question number 1. So these questions ask us to find how many 3-digit numbers can be formed by using the digits 1 to 9 if no digit is repeated. That means without repeating any digit, we have to find number of 3-digit numbers formed using the digits 1 to 9. So let's start the solution. Given that 3-digit numbers have to be formed using the digits 1 to 9. Okay, so we have here 9 digits to form 3-digit numbers. Let's find how many 3-digit numbers can be formed using the digits 1 to 9. Here, it's crucial to note that the order of the digits matters. Okay, so here order of the digits matter. You should note this point. To solve this, we need to find the number of permutations of 9 different digits taken 3 at a time. Okay, so therefore there will be as many 3-digit numbers as there are permutations of 9 different digits taken 3 at a time. Okay, so the formula for permutations we will know, NPR is equal to n factorial upon n minus r factorial. So applying this formula, we calculate 9p3. This is equal to 9 factorial upon 9 minus 3 factorial. Okay, and after simplifying, we get 9 factorial upon 6 factorial. So 9p3 is equal to 9 factorial upon 6 factorial. Now we simplify the expression by using the formula n factorial is equal to n times n minus 1 factorial. Okay, so 9p3, it will become 9 into 8 into 7 into 6 factorial upon 6 factorial. Okay, and here you can see 6 factorial is common in numerator and denominator. Okay, so now we can cancel them to each other. Okay, so finally we compute the product 9 into 8 into 7. This is equal to 504. Okay, so 9p3, this is equal to 504. So therefore the number of 3-digit numbers using digits 1 to 9 with no repetition is 504. Okay, so our final answer will be 504. So I hope this question is clear to all of you. Okay, so now let's move to the next question. So look at here question number 2. So question number 2 asks us to find 4-digit numbers are there with no digit repeated. Okay, so how many 4-digit numbers can be formed if no digit is repeated? That we have to find here. So students, first of all, try it yourself. Okay, how would you approach this question? So let's start the solution step by step. So let's start by identifying the structure of a 4-digit numbers. Okay, so 4-digit numbers consist of 4 places: thousands place, hundred place, tens place, and unit place. Okay, so there are 4 places for the digits in a 4-digit numbers. Okay, so basically we have to now find the choices for each places. Okay, and then we will get, by using multiplication principle, the number of 4-digit numbers with no digit repeated. Okay, so for the thousand place, we have a specific constant. Okay, that is the digit, uh, first digit. Okay, thousand digit cannot be zero. Okay, so if it were zero, then the number would not be a 4-digit number. That times the number will become 3-digit numbers. Okay, so for the thousand place, here we have a restriction, that is zero cannot be in thousand place. Okay, so the digit cannot be zero. Okay, so because then the number would be become a 3-digit number, but we need a 4-digit numbers. So we have 9 possible choices for the thousand place. Okay, so this is 1 to 9. We can take any number between 1 to 9 for thousand place. So we have here 9 options for thousand place. Okay, now moving to the 100 place. Okay, so we must remember that no digit can be repeated. Okay, so since one digit is already used in the thousands place, so we have now 9 remaining choices for the 100 place. Okay, so for 100 place, we have 9 digits to fill this place. Okay, now next, for the tens place, we have already used 2 digits for the thousands place and 100 place. Okay, so now we have 8 digits are remaining. Okay, and these 8 digits, okay, 8 digits can be used for the tens place. So for the 10 place, we have 8 choices to fill it. Okay, so now finally for the unit place, after filling the first 3 places, after filling thousand place, 100 place and 10 place, we are remaining 7 digits. Okay, so we have now 7 digits left to choose from. Okay, so for unit place, there are 7 digits remaining to fill the units place. Clear? I hope it's clear to all of you. By the multiplication principle, it says that if there are m ways to do one task and n ways to do another task, then both tasks can be done in m into n ways. Okay, so now we are going to apply multiplication principle to get the answer of this question. So using the multiplication principle, we calculate the total number of 4-digit numbers by multiplying the number of choices for each places. Okay, thousands, hundreds, tens and unit places. Okay, so then we will get the total number of 4-digit numbers without any digit repeat. So the calculation is straightforward. Okay, so 9 choices for the 1000 place, 9 for the 100 place, 8 for the 10th place. Okay, and 7 for the unit place. Okay, so multiplying these and gives us 9 into 8 into, so 9 into 9 into 8 into 7. Okay, and after multiplying you will get this is equal to 4536. Clear? So therefore the total number of 4-digit numbers with no repeated digits is 4536. Okay, so this is our final answer. So I hope it is clear to all of you. Okay, so now let's move to the next question. So in this question, the question asks us how many 3-digit even numbers can be made using the digits 1, 2, 3, 4, 6, 7 if no digit is repeated. Okay, so let's think about this question. How would you solve this question? Okay, so let's start the solution. Given that 3-digit even numbers are to be formed using the given 6 digits 1, 2, 3, 4, 6 and 7, okay, without repeating the digits. Then unit digits can be filled in 3 ways by any of the digits 2, 4 or 6, since the number must be even. Okay, so the units digits can only be one of the even digits, that is 2, 4 or 6. Okay, this gives us 3 choices for the units digit. Since the digits cannot be repeated in the 3-digit numbers, okay, so unit place is already occupied with the digit which is even. Okay, so the hundreds and tens place is to be filled by the remaining 5 digits. To find the number of ways to fill the hundreds and tens places, we use permutations. Okay, specifically we need to calculate the permutation of 5 different digits taken 2 at a time. So what is that permutation? So the formula for the permutations is NPR is equal to n factorial upon n minus r factorial. Okay, here n is 5, r is 2. So we calculate 5p2. This is equal to 5 factorial upon 5 minus 2 factorial. Now we will know the formula n factorial is equal to n times n minus 1 factorial. Okay, we will know this formula. So using this formula and simplifying, we will get 5 factorial upon 3 factorial. This is equal to 5 into 4 into 3 factorial upon 3 factorial. Okay, so here we got, after simplifying, that is 20. So 5p2, this is equal to 20. Now remember multiplication principle. So it says that if there are m ways to do one task and n ways to do another task, then there are m into n ways to do both tasks together. Okay, so finally we will now use the multiplication principle and then we will get the required number of 3-digit numbers, that is 3 into 20 equal to 60. Okay, so the final answer is 60. Now look at question number 4. So this question asks us to find the number of 4-digit numbers that can be formed using the digits 1, 2, 3, 4, 5. If no digit is repeated, so how many of these will be even? Okay, that we have to also find. So let's see how to solve this question. So let's start the solution. So 4-digit numbers are to be formed using the digits 1, 2, 3, 4 and 5. Okay, so to find the total number of 4-digit numbers, we need to calculate the permutations of 5 different digits taken 4 at a time. Okay, so the formula for the permutation is given by NPR is equal to n factorial upon n minus r factorial. Here n is 5 and r is 4, so we calculate 5p4 is equal to 5 factorial upon 5 minus 4 factorial. Now let's simplify the expression. We have 5 factorial upon 1 factorial, and calculating further we get 5 factorial. This is equal to 5 into 4 into 3 into 2 into 1, and finally we have 120. So let's see, amongst the 4-digit numbers formed by using the digits 1, 2, 3, 4, 5, even numbers end with either 2 or 4. Okay, so for the unit digits, here we have 2 choices now. So the number of ways in which unit place is filled with digits is 2. Since the digits are not repeated, so with the unit place occupied by an even digit, so we have 4 remaining digits to fill the other 3 places. The remaining 3 places need to fill with the remaining 4 digits. So the number of ways to fill the remaining places is given by the permutation of 4 different digits taken 3 at a time. The formula for the permutation is NPR is equal to n factorial upon n minus r factorial. Here n is 4 and 3 r is equal to 3. So we calculate 4p3 is equal to 4 factorial upon 4 minus 3 factorial. So calculating further and using the formula n factorial is equal to n times n minus 1 times the order of 3 into 2 into 1. Okay, so it will give us 4 factorial upon 1 factorial, and this is simply equal to 4 into 3 into 2 into 1. So finally we got 24. So 4p3 is equal to 24. Now by the multiplication principle, it says that if there are m ways to do one task and n ways to do another task, then there are m into n ways to do both tasks. Okay. So now applying this rule, okay, and then find the total number of 4-digit numbers, okay, even numbers. So the total number of 4-digit even numbers using the digits 1 to 5 without repetition is 24 into 2 is equal to 48. Now look at question number 5. So this question is from a committee of 8 persons. In how many ways can we choose a chairman and a vice chairman, assuming one person cannot hold more than one position? Okay, so let's try to solve this question. So let's start the solution. So from a committee of 8 persons, a chairman and a vice chairman are to be chosen in such a way that one person cannot hold more than one position. So here the number of ways of choosing a chairman and a vice chairman is the permutation of 8 different objects taken 2 at a time. The required number of ways is 8p2. This is equal to 8 factorial upon 8 minus 2 factorial. Okay, since we know the formula for NPR is n factorial upon n minus r factorial. Here n is 8 and r is 2. So we have 8p2 is equal to 8 factorial upon 8 minus 2 factorial. Simplifying further, and we calculate 8 factorial upon 6 factorial. This reduces to 8 into 7 into 6 factorial upon 6 factorial. And notice how the 6 factorial terms cancel out here. So therefore the number of ways of choosing a chairman and a vice chairman is 56. Okay. Now look at question number 6. Okay, so this question asks us to find n, the value of n, if n minus 1 p3 is to n p4 is equal to 1 is to 9. Okay, let's start the solution. So here we have n minus 1 p3 upon n p4 equal to 1 by 9. So next we substitute the permutation formula into our equation. Okay, so recall that NPR is equal to n factorial upon n minus r factorial. Okay, so using this formula and simplifying the given equation, so it implies n minus 1 factorial upon n minus 1 minus 3 factorial divided by n factorial upon n minus 4 factorial. This is equal to 1 by 9. Now let's simplify the equation further. So we multiply the fractions to get n minus 1 factorial upon n minus 4 factorial multiplied with n minus 4 factorial upon n factorial. This is equal to 1 by 9. Notice here how the n minus 4 factorial terms will be cancelled out. So now cancel out n minus 4 factorial, we get n minus 1 factorial upon n times n minus 1 factorial. This is equal to 1 by 9. Okay, and observe here n minus 1 factorial will be cancelled out. So cancel out n minus 1 factorial and further simplify, the equation will become 1 by n equal to 1 by 9. So therefore the value of n is equal to 9. Okay, so our answer will be 9. So I hope this question is clear to all of you. So now let's move to the next question. This question asks us to find the value of r if we have 5pr equal to 2 to the power 6 pr minus 1. Okay, 6pr minus 1. And the second part we have 5p4 equal to 5pr equal to 6pr minus 1. Okay, so we have to find here the value of r. So let's start the solution. Here we have 5pr equal to 2 times 6pr minus 1. It implies 5 factorial upon 5 minus r factorial. This is equal to 2 times 6 factorial upon 6 minus r plus 1 factorial. Since npr equal to n factorial upon n minus r factorial. Now we simplify the right side by expressing 6 factorial as 6 into 5 factorial, and this gives us 5 factorial upon 5 minus r factorial. This is equal to 2 into 6 into 5 factorial upon 7 minus r into 6 minus r into 5 minus r factorial. Cancel out 5 factorial and 5 minus r factorial. We get 1 equal to 2 into 6 upon 7 minus r into 6 minus r. So we solve for here 7 minus r into 6 minus r equal to 12. So now expanding the left side, okay, and we get 42 minus 6r minus 7r plus r square is equal to 12. So this is a quadratic equation. So rearranging the terms, and we have the quadratic equation r square minus 13r plus 30 equal to 0. Now factoring the quadratic equation, we find r minus 3 multiplied with r minus 10 equal to 0. From the factored equation, we determine that r equal to 3 or r equal to 10. So we know that npr equal to n factorial upon n minus r factorial, where 0 less than equal to r less than equal to n. So therefore 0 less than equal to r less than equal to 5, and here r not equal to 10. So we narrow down the possible values of r. So therefore r equal to 3. So, and second equation we have 5pr equal to 6pr minus 1. So using the formula npr equal to n factorial upon n minus r factorial. Okay, so it implies 5 factorial upon 5 minus r factorial. This is equal to 6 factorial upon 6 minus r plus 1 factorial. Since n factorial is equal to n times n minus 1 factorial, so it implies 5 factorial upon 5 minus r factorial is equal to 6 times 5 factorial upon 7 minus r factorial. It implies 5 factorial upon 5 minus r factorial is equal to 6 into 5 factorial upon 7 minus r into 6 minus r into 5 minus r factorial. So now we will see how to cancel 5 minus r factorial. So cancel out 5 factorial and 5 minus r factorial. We get 1 equal to 6 upon 7 minus r into 6 minus r. It implies 7 minus r into 6 minus r equal to 6. And it implies 42 minus 7r minus 6r plus r square minus 6 equal to 0. It implies r square minus 13r plus 36 equal to 0. And after factoring the quadratic equation, we obtain r minus 4 into r minus 9 equal to 0. It implies r equal to 4 or r equal to 9. So now recall the definition of permutations. npr equal to n factorial upon n minus r factorial, where 0 less than equal to r less than equal to n. Therefore 0 less than equal to r less than equal to 5 and r not equal to 9. So we conclude that the valid solution for r is 4. Okay, so the value of r will be 4. So now let's move to the next question. So this question asks us to find how many words with or without meaning can be formed using all the letters of the word equation, using each letter exactly once times. Okay, so let's start the solution. So here there are 8 different letters in the word equation. Okay, so in equation word there we have 8 different letters. Next, we calculate the number of permutations of these 8 different letters. Okay, so the formula for the permutation of n objects taken r at a time is given by npr equal to n factorial upon n minus r factorial. Okay, since we are using 8 letters, so we have 8p8 equal to 8 factorial upon 8 minus 8 factorial. And this is equal to 8 factorial upon 0 factorial, and since 0 factorial is 1, so this is equal to 8 factorial simply. So thus the number of words that can be formed from equation, okay, from equation word is 8 factorial is equal to 40,320. Okay, so I hope it is clear to all of you. So now let's move to the next question. This question asks us how many words with or without meaning can be made from the letters of the word Monday, assuming that no letter is repeated and if 4 letters are used at a time. Okay, so let's start the solution. There are 6 different letters in the word Monday. Okay, Monday. Now let's focus on forming 4 letter words. Okay, from these 6 letters, so the number of permutations of 6 different objects taken 4 at a time is basically denoted as 6p4. So we will know the formula npr equal to n factorial upon n minus r factorial. Okay, so using this formula we can find 6p4 equal to 6 factorial upon 6 minus 4 factorial. And since we know n factorial is equal to n times n minus 1 factorial, so 6 factorial upon 2 factorial, this is equal to 6 into 5 into 4 into 3 into 2 factorial upon 2 factorial. After performing the multiplication, 6 into 5 into 4 into 3 equal to 360. Okay, so 6p4 equal to 360. Therefore, the number of 4 letter words that can be formed from the letters of the word Monday without repetition is 360. Clear? I think you are getting my point and it's clear to all of you. So now let's move to the next question. This question asks us to find in how many of the distinct permutations of the letters in Mississippi do the four eyes not come together. Okay, so let's find how can we solve this question. So let's start the solution. So in the given word Mississippi, I appears 4 times. Okay, and S appears 4 times, P appears 2 times. Okay, and M appears just once. So note these important points. Then using theorem 4, the number of permutations of n objects where p1 object are of the first kind, p2 are the second kind, and dot 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 pk are the kth kind, and the rest of the any object are the different kinds. And the number of permutation is basically n factorial upon p1 factorial into p2 factorial into dot dot pk factorial. Applying this formula, the number of distinct permutations of the letters in the given word is 11 factorial upon 4 factorial into 4 factorial into 2 factorial. Okay, here 11 is the total number of letters and the factorials in the denominator account for the repetitions. Now let's simplify this expression. We have 11 into 10 into 9 into 8 into 7 into 6 into 5 into 4 factorial upon 4 factorial into 4 into 3 into 2 into 1 into 2 into 1. Continuing with the simplification, we get 11 into 10 into 9 into 8 into 7 into 6 into 5 upon 4 into 3 into 2 into 1 into 2 into 1. After performing the calculations, we find that the total number of distinct permutations is 34,650. Okay, so the number of distinct permutations of the letters in the given word is 34,650. So let's start by identify the components of the word Mississippi. Okay, so we have 4 I's and which are crucial to our problem. So here there are 4 I's in the given word, and when they occur together, they are treated as a single object. Okay, so 4i will be treated as a single object for the time being. The single object together with the remaining 7 sub objects will account for 8 objects. So therefore, by using the theorem 4 states that the number of permutations of n objects where p1 objects are the first kind, p2 are the second kind, and dot 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 pk are the kth kind, then the rest if any are the different kinds is basically n factorial upon p1 factorial into p2 factorial into dot 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 pk factorial. Applying this formula, we arrange these 8 objects which include 4 a's, 2 p's. Okay, so the calculation is 8 factorial divided by 4 factorial into 2 factorial, that is 840 ways. So here we got 840 arrangements where all i's occur together. Okay, thus the number of distinct permutations of the letters in Mississippi word in which 4 i's do not come together is simply equal to 11 factorial upon 4 factorial into 4 factorial into 2 factorial minus 8 factorial upon 4 factorial into 2 factorial. This is equal to 34,650 minus 840, and this is simply equal to 33,810. Okay, so our answer will be 33,810. Clear? I think this question is clear to all of you. Now, look at question number 11. The question asks, in how many ways can the letters of the word permutations be arranged if the words start with P and end with S? Okay, in first part we have, and in second part we have vowels are vowel together. In third part we have there are vowels 4 letters between P and S. Okay, so let's solve this question. So let's start the solution. So in the word permutations, there are 2T and all the other letters appear only once. Okay, in the word permutations. So now consider a specific scenario. Okay, so here if P and S are fixed at the extreme ends. Okay, so P at the left end and S at the right end, then 10 letters are left to us. So then using the theorem 4 states that the number of permutations of the n objects where P1 objects are first kind identical, P2 are the second kind identical, and dot dot pk are the kth kind of identical, and the rest if any other different kinds is n factorial upon p1 factorial into p2 factorial into dot 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 pk factorial. So let's calculate the arrangements. We have 10 letters left to arrange, and we need to account for the repetition of the t's. Okay, so the required number of arrangements is 10 factorial upon 2 factorial. So now let's break down the calculation. So 10 factorial is basically 10 times 9 into 8 into 7 into 6 into 5 into 4 into 3 into 2 factorial. Okay, divided by 2 factorial. So after simplifying, we get 10 into 9 into 8 into 7 into 6 into 4 into 3. This is equal to 1814400. So therefore, the number of ways letters arrange of the word permutations start with P and end with S is 1814400. Okay, clear? I think it's clear to all of you. So now look at second part of this question. Okay, so in second part in this question we have there are 5 vowels in the given word. Okay, and vowels are vowel together. Okay, will be vowel together. So these 5 vowels will treat as a one object. Since the vowels must always occur together, so we treat them as a single object. So this single object together with the remaining 7 objects will account for 8 objects. Now using the theorem 4, okay, so theorem 4 says the number of permutations of n objects where p1 objects are the first kind, p2 are the second kind, and dot dot pk are the kth kind. The rest, if any, are the different kinds is n factorial upon p1 factorial into p2 factorial into dot 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 pk factorial. So applying this formula, we arrange these 8 objects. So accounting for the 2 identical t's in 8 factorial upon 2 factorial ways. Okay, so these 8 objects in which there are 2 t's can be arranged in 8 factorial upon 2 factorial ways. So corresponding to each of these arrangements, the 5 different vowels can be arranged in 5 factorial ways. So now we will multiply it with the 8 objects in which there are 2 t's can be arranged in 8 factorial upon 2 factorial ways. So therefore, by multiplication principle states that if there are m ways to do one task and n ways to do another task, then there are m into n ways to do both tasks together. The number of arrangements is 8 factorial upon 2 factorial into 5 factorial. And since we know n factorial is equal to n times n minus 1 factorial, so this is equal to 8 into 7 into 6 into 5 into 4 into 3 into 2 factorial upon 2 factorial multiplied with 5 into 4 into 3 into 2 into 1. So simplify it. So further simplify, we will get this is equal to 2419200. So therefore, the number of ways letters arrange of the word permutations where vowels are all together is 2419200. Now moving to the third part. Okay, so the letters of the have to be arranged in such a way that there are always 4 letters between P and S. So therefore, by using theorem 4, the theorem 4 states that the number of permutations of n objects where P1 objects are the first kind, P2 are the second kind, and Pk are the kth kind, and the rest, if any, are the different kinds is n factorial upon P1 factorial into P2 factorial into Pk factorial. So therefore, in a way, the places of P and S are fixed here. Okay, so this means that these 2 letters will always occupy specific places in our arrangements. The remaining 10 letters in which there are 2 t's can be arranged in 10 factorial upon 2 factorial ways. Also, the letters P and S can be placed such that there are 4 letters between them. So this is equal to 2 into 7 equal to 14 ways. Therefore, by multiplication principle, if there are m ways to do one task and n ways to do another task, then there are m into n ways to do both the tasks together. The number of arrangements is 10 factorial upon 2 factorial multiplied with 14, and simplifying it and using n factorial n times n minus 1, we will get this is equal to 10 into 9 into 8 into 7 into 6 into 5 into 4 into 3 into 2 factorial upon 2 factorial multiplied with 14. So further simplifying, you will get 25401600. Okay, so the number of arrangements is 25401600. Therefore, the number of ways letters arrange of the word permutations with 4 letters between P and S is 25401600. Clear? I think it is clear to all of you. So students, that's all for today's lecture, and thank you for attending this lecture.